All right, let's jump right into this explainer. Today, we're unpacking a truly fascinating proposal that's looking to completely revolutionize decentralized viral hemorrhagic fever testing. We're diving into a project by a US tech company called DBbun. And let me tell you, what they're proposing isn't just some tiny incremental update to healthcare training. It's a fundamental shift in how we prepare frontline workers for some of the absolute most dangerous environments on Earth.
I mean, really think about that for a second. How do you actually train for Ebola without the internet? This question instantly sets the massive stakes for what we're talking about today. When a severe outbreak hits, frontline personnel are usually operating in remote, highly resource-strained environments. Standard digital solutions, the ones that rely on constant cloud connectivity, high-speed Wi-Fi, endless server pings, they just flat out fail out there. Yet these workers are dealing with literal life-or-death procedures. They're collecting specimens, wearing complex protective gear, running diagnostic tests, and a single mistake can be catastrophic.
To unpack this whole proposal, we're going to look at the frontline training gap, DBbun's offline companion solution, their 4 modes of mastery, the local AI guardrails they've put in place, and finally, the path to impact.
Starting with Section 1, the frontline training gap, and what it really means to train in the harshest environments.
So here's the fundamental problem. Static manuals just cannot provide the immediate interactive feedback you desperately need when lives are on the line. Imagine you're handed a dense paper manual during a one-off classroom training session. You read it, maybe it makes sense in the room, but then you're deployed to a remote testing site. The reality in the field is radically different. You need point-of-work support right there in the moment. You need rapid protocol updates because virus guidelines change fast. And above all, you need strict safety. A piece of paper can't watch you practice, it can't correct you in real time, and it definitely doesn't give a supervisor any audible proof that you've mastered the critical steps.
And the constraints these workers face are just brutal. Decentralized testing often means zero reliable electricity and definitely no internet connectivity. There's no fancy laboratory infrastructure. Plus, workers are wearing incredibly bulky personal protective equipment, PPE. If you've ever tried to do anything requiring fine motor skills while wearing thick, double-layered hazmat gloves and completely foggy goggles, you know your dexterity and visibility basically plummet to zero. Add to that the high-stakes biosafety rule. You absolutely cannot practice using live, highly infectious specimens. You just have to get it right the very first time you do it for real.
Moving on to Section 2, the offline companion solution, where we look at moving from paper to interactive software.
To bridge this hazardous gap, DBbun is proposing what they call an executable companion. Think of this as a localized digital mentor that lives right there on a tablet or laptop. It takes approved medical procedures, like a WHO infographic for Ebola infection prevention, and converts the whole thing into an offline, multilingual tool. It guides your work step by step. It simulates critical decisions so you can safely practice. If you mess up, it immediately remediates the error. It verifies your competency for your supervisors. And, this is crucial, it preserves complete traceability back to the original governing source document. And the best part? All of this happens locally. Not a single drop of internet connectivity required.
It's a literal game changer. The old way is incredibly passive. It's reading heavy. And if you need to update it, you're printing and shipping thousands of new binders across international borders. The new way, the DBbun Companion, gives you branching practice where your choices have simulated consequences. It gives immediate remediation to fix misunderstandings right at the point of work. It's digital support that transforms passive reading into active, measurable competency.
Which brings us to Section 3, 4 modes of mastery. Think of this as a flight simulator for frontline workers. To make this actually effective, the software is divided into 4 really specific linked modes. First, there's guided mode, which acts as a stepwise job aid with mandatory safety checkpoints. Next up is practice mode. This is your safe sandbox. You can rehearse the workflow over and over without the pressure of failing a certification. Then comes assessment mode. This is where things get real. It hits you with branching decisions, tests your ability to spot unsafe conditions, and scores you on critical errors. Finally, supervisor mode gives managers digital checklists to observe workers and generates real-time readiness summaries. Together, these modes let workers safely practice and fail in a simulation before they ever touch anything infectious.
But hey, all this software is totally useless if you can't actually operate it. Try sending a text message while wearing thick oven mitts. Now imagine those mitts are double-layered hazmat gloves and you're handling infectious samples. That's exactly why DBbun outlines highly specific user experience choices. massive controls you can tap with zero dexterity, minimal text entry because typing is virtually impossible, high contrast visual sequences, and short audio prompts to help overcome the visibility and hearing limitations of PPE. Even the scrolling is limited. Every single design choice is dictated by the harsh physical reality of the frontline worker.
Now, I absolutely love this number, 30. That number represents the target minutes it takes their system to draft a structured, interactive module straight from an approved source document. Talk about rapid deployment capability. When an outbreak hits, you don't have months to code a new training app from scratch. You need to turn a brand new health directive into an interactive training tool almost instantly. Okay, Section 4. Local AI guardrails, ensuring safety and accuracy.
I know, integrating AI into medical tech usually raises some massive red flags, but the absolute core of DBbun's safety protocol is this concept right here, source-locked. This is paramount. It means the system relies on strict deterministic rules. If they happen to use optional compact AI models to provide plain language explanations or multilingual help, that AI is physically restricted to an approved source pack. It's deterministic, meaning it literally cannot hallucinate. It absolutely cannot change procedures, it won't invent new instructions out of thin air, and it can never override the core safety logic. The approved clinical source is the unquestionable law.
They've drawn some really strict, hard lines here on the boundaries of this technology. Look at what it does not do. It does not diagnose patients. It does not handle actual specimens. It does not invent instructions. The app is strictly an educational and competency companion. By drawing these lines so clearly, the proposal ensures that regulatory bodies and ministries of health can actually trust the system. It trains workers safely without the software secretly trying to practice medicine without a license.
And finally, Section 5, the path to impact, scaling preparedness. Now that we have a handle on the tech, let's look at the actual 18-month roadmap for rolling this out. They aren't just dropping an app and walking away. Months 1 to 3 are purely focused on governance and establishing expert review pathways. By months 4 to 6, they're aiming for a minimum viable product that works completely offline. Months 7 to 9 introduce a multilingual beta, specifically targeting French, Swahili, and Lingala to fit the realities of regions historically hit by these viruses. By months 16 to 18, the goal is a full production package and a global release. And crucially, every single stage has strict go, no-go criteria. If it fails a safety check, the whole thing stops.
So what does success actually look like? Ultimately, it hinges on some very exact performance targets. They're aiming to prove at least a 30% mean improvement in learning and a rigorous standard of at least 85% mastery of critical steps after a user goes through remediation. Plus, the outputs of this grant have to comply with the Gates Foundation's global access requirements, meaning the training content, the assessment frameworks, and the implementation materials will be broadly accessible and affordable to the high-risk settings that actually need them the most.
Here's one last incredibly powerful number. 5. Just 5 business days is their rapid target for publishing a reviewed protocol update. When a virus mutates, or when health organizations discover a slightly safer way to handle waste, guidelines inevitably change. Under the old system, updating paper manuals worldwide takes months. With this system, they aim to ingest the new document, update the executable logic, and have a locally deployable update ready in less than a week. That is huge. So as we wrap up this explainer, I want to leave you with a thought to consider. We know for a fact that the next decentralized epidemic won't necessarily strike where there's perfect internet and pristine, climate-controlled laboratories. It's going to strike at the edges. Could these offline, source-locked, interactive competency companions be the ultimate key to ensuring that every single frontline worker, no matter how remote, is perfectly prepared? It is a fascinating glimpse into the future of digital health equity, and it really fundamentally changes how we think about readiness. Thanks for joining me for this explainer, and keep questioning how technology can better serve those putting their lives on the line.